This is the introduction video for radical functions and equations. The learning outcomes are to review solving rational, absolute value, and quadratic equations. Solve radical equations with one or two radical signs, and to solve quadratic-like equations that contain rational exponents. To begin, we want to make sure that we know how to solve rational equations, and the big thing about that is that we need to know how to determine domain restrictions. We're going to do the same thing when we talk about radical equations. Remind ourselves that y is equal to the square root of x is our parent function, and the graph of that of our parent function looks something like this, which had a domain that said that it could include 0 and go all the way to infinity. So notice we cannot have a negative number inside the radical, because we learned that if we were going to get the square root of a -4, we're going to get like 2i, which is imaginary and not on my graph. The other thing we need to do is remind ourselves of how to do absolute value. The big thing there is that we had to isolate the absolute value function when we were solving. The same thing's going to happen when we're having our radical. So we might have something that says x plus 2 here, and then maybe a -5 is equal to 0. Then the first thing we're going to have to do is to move this -5 to the other side. And then now that we've isolated the radical on this side, then we can use our techniques in order to get rid of it. In this case, since this is a square root function, then we would square both sides, and we would get x plus 2 is equal to 25. And then we can see that our value for x, and then we can check it to make sure it works. Now remember that when we have the square root of x plus 2, that's a transformation that says to make it go 2 to the left. So it actually starts here. So we can have a -1 or a -2 as an answer, but it would not be able to have -5, let's say. So that's the reason why we need to remind ourselves that our domain restrictions, or our domain for our radical functions, and because we're going to have to check that, just like we did that with the rational functions. Lastly, we need to make sure we know how to do quadratic equations, because just like we did when we did rational equations, that when we're going around solving, we might end up with a quadratic equation or a linear equation that we are going to have to solve. So that's all I want to say about making sure you know how to do or solve those types of equations. So when solving radical equations, the very first thing that we need to do is to determine our restriction. So in other words, whatever we have inside of our radical, so let it say it's the square root of x minus 5, then we got to make sure that we remember that the x minus 5 must be equal to 0 or greater than 0. So from here we can decide that our domain will actually have to be all those numbers equal to 5 or greater than 5. So this is how we find our domain restriction. The next thing we need to do is to isolate the radical. So if I had plus 3 is equal to 23, then the first thing I need to do is to get rid of this 3, and I'll have the square root of x minus 5 is equal to 20. Once we isolated the radical, then we need to get rid of the radical sign. So if this is a square root, then I am going to square both sides. However, if this was a cube root, then I would have to cube both sides. So I just wanted to remind you of that. And we'll talk a little bit about here is that if we had one that created a new radical, then we would have to do this process again. And I believe one of these examples, maybe that very first one, actually does an example that I'm trying to refer to. In this case, we only have the one radical. We keep on going, and then now we can solve for our variable. So notice that the cube root and the cube would undo each other, so we would end up with x minus 5, and then we would end up with some huge number of 20 times 20 times 20. That would be 8,000. That's equal to x minus 5, and then we can solve and find that to be 795. And then we just need to make sure we check our answer with our restriction. As long as this is bigger than 5, I think we're okay, and then we would put our solution set to be 795. That's the only number in our solution. So again, I do recommend that you take a look at these videos. One of them is going to be as simple as the one we just covered here, but another one will have 2 radicals in there. The big thing that I do want to remind you of is this situation. If you have something that says x minus the square root of x plus 2 is equal to 3, that I do want to remind you that when we're isolating our radical here, we're going to subtract x to both sides. So I have negative square root of x plus 2 is equal to 3 minus x. Now I'm going to get rid of this negative, so I'm going to have the square root of x plus 2 is equal to positive x minus 3. Don't forget, what we're doing is multiplying both sides by negative, and that's how I'm getting this guy right here. And now when you're ready to get rid of the radical, make sure that you put one set of parentheses on the left and one set of parentheses on the right. So that means on the left side, my square root and my square will kind of undo each other, which means we'll just have x plus 2 on this side. However, over here on the right side, remind yourself that this is x minus 3 times x minus 3, so you're going to have to actually multiply that out, or remind yourself to do FOIL. And then when you do that, you're going to see you're going to get a quadratic equation, and you need to be able to solve quadratic equations. So the big thing I wanted to remind you of was that you need to make sure that when you're ready to take the square or the cube or whatever of both sides, you have one set of parentheses on the left and one set of parentheses on the right. So for the last learning outcome, which is to solve quadratic-like equations containing rational exponents, let's first recall what it means to have a rational exponent. So if we have something that says x to the 2/3, I want to remind you that that means it's the cube root of x squared. Or it could also be the cube root of x, the whole thing squared. So it just depends on the situation. So for example, if I would have had 8 to the 2/3, then the first thing I can see is that this is the cube root of 8 squared. So the first question I want to ask you, do you know the cube root of 64? If you do, then keep cranking. But if you don't, then we could have also written this as the cube root of 8 and then square it. And the cube root of 8 is 2, and then when we square it, it's equal to 4. And believe it or not, the cube root of 64 is 4. So we would get the same answer. So one of the big things I want to remind you of is that if you have anything that looks like the fraction m over n for your exponent, that is the nth root of x to the m power. And we can write it such that we have the nth root first and then the exponent of m. So either one of those will work. Now the other thing that might be very helpful when we're trying to solve quadratic-like equations is going to be the fact that if you have x to the 1/3 and you square that, so I want to remind you that when you square something like this, you actually are multiplying these two exponents. So we would end up with x, and remember I'm multiplying 1/3 times 2, make that over 1, so I'm going to see that this is the same thing as x as 2/3. So what I want to remind you of is that you can have x to the 1/3, and then we can square it, and we're going to end up with x to the 2/3. Let me show you where that comes in handy. One of the example videos will actually go into greater detail about this, but what I want to show you is that we can use u substitution and let u equal to the middle term without the coefficient, so without the negative. I would have x plus 1 to the 1/3. And if I square u, that means I squared this side, and I'm going to square this side, we're going to see that this is going to give me x plus 1 to the 2/3. And now we can see that our equation can now be written as u squared minus u minus 2 is equal to 0. And this is a quadratic equation. We can factor this into u and 2 and 1. I need a negative 2 and a positive 1. And then we can see that u is equal to 2 and u is equal to negative 1. So then we have to undo the u's. All that means is I have to solve the equation of x plus 1 to the 1/3 is equal to 2. And remember, that is the cube root of x plus 1 is equal to 2. So now you know how to solve this one since the radical is already isolated. And we would do the same thing for this guy right here. So we would have x plus 1 to the 1/3 is equal to negative 1. And then we have the cube root of x plus 1 is equal to negative 1. If we take a look at our domain restrictions for the cube root, remember that our cube root function of x, our parent function, actually looks like this. And we can see our domain is all real numbers. So that means we don't have any restrictions. And it's okay that the answer is equal to negative 1. It's the square root function that does not allow it to equal to a negative 1. So you can see that we have talked about the u substitution, and more importantly, we have talked about making sure that we check with the domain restrictions. But if it's a square root is where we have our issue. Cube root, there are no domain restrictions. And that concludes this video.